5.5 is going to deal with a lot of the same stuff that 5.3 and 5.4 dealt with the verifications and with the equation manipulation, except for we're going to add the rest of those identities on the front, in the front of your book, plus one other set of identities that you'll need to know as well. Okay? So ideally, you should already have everything in the front of the book memorized since you've had since the end of August, right?
Yeah.
We're just going to add one more set to the mix now. This one is in the front of the book. Multiple angle formulas. Okay, these are also called double angle formulas because the idea is if you have sine of, give it a second, sine of any value doubled inside of here, if I don't know the doubled value but I know half of it, this will allow me to manipulate and find those and be able to solve this even though I don't know what that part is, the sine of 2u. Now these are all in the front of the book. I'm not going to leave this up here too long for you guys to copy down or anything. Feel free to open up to the front of your book and look at that as the reference. But notice cosine has 3 different versions. And you're going to want to use, any of those 3 will usually work. One will usually work best for that problem you're doing. So it depends. If you have nothing but cosine, I'd probably work with the one that says 2 cosine and with no sine in it. If you have nothing but sines to work with, I'd probably work with the sine squared. Excuse me. If you have anything where it's Pythagoreans going on, I'm probably leaning this direction because things probably will cancel off. So it's kind of a judgment call. Now the other nice thing is if you're doing tangent, well, if you already know sine and cosine of 2u, you can just divide those and get tangent. Sometimes that makes things easier, sometimes it makes things worse, but it's another option. But if I have something like this and I'm asked to solve it, okay? So solve cosine 2x plus cosine x equals 0. Can't solve it the way it is because I can't separate out cosine of x. Cosine of 2x and cosine of x are 2 different values, so I can't really work with those directly. So I need to replace the cosine of 2x. Since I have cosine of x here, I'm going to replace it with that, with the one that has cosine of x in it, not with sine, because I don't want to deal with sine. I only want to work with one of them. So when I do that, that's going to replace cosine of 2x with 2 cosine of x, or 2 cosine squared x, sorry, plus 1. So that replaces that whole thing, and then you still have the cosine of x here. Is it minus 1?
Yeah.
I'm sorry, that's a minus sign. See, I'm not the one that has to. I'm not the one that has to have it memorized. So for this, 2 cosine squared x minus 1 plus cosine of x. This is the same as the stuff you were doing. You just have to solve for cosine of x and then solve for x. So rearrange it first off so I can factor it easier. It's already equal to 0, so I'm just going to swap the places of the x and the 1, the cosine of x and the 1. Now, this will split out into what and what? 2 cosine x and cosine x. Now, you're going to have 1 and 1 to multiply to give you 1. And 1 positive, 1 negative. Where are those numbers at? Yeah, you want minus and plus, so that way when you take the positive 1 times 2, plus the negative 1 times 1, add them up, you get 1 cosine. Then what? Set both pieces equal to 0. So I have, this one will turn into cosine of x is equal to what? 1/2. The other one's cosine of x is equal to negative 1. Think unit circle, when is cosine of x 1/2? Pi over 3. Where else? 5 pi over 3. When is cosine of x negative 1? At pi. Okay? Now, if they were specifying between 0 and 2 pi, you would answer these 3 things. They're not, so they want general solution. So what do I need to tack on to all of them? Plus 2n pi or 2 pi n, however you want to write it. For all of them. Because these things, if I think about where these two are at on the unit circle, I can't just add the same number repeatedly and hit both of them, right? The other one's over here. Actually, you know what? We might be able to shortcut that. If you left it like this one's bizarre enough, I would just take this. But does anybody see something else I might be able to do? I never actually thought about it until I drew all 3 of them on the same axis. 2 pi over 3n. Yeah, if you actually, and this one's creative enough, if you just had this, that's fine. But because a third of a rotation, third of a rotation, third of a rotation, all the way around, you can actually do that as plus 2 pi over 3n repeatedly. So if you had that, that's actually even a better answer. I wouldn't necessarily expect you to be able to spot that quickly on a test. And I would just take this bottom one if you like, but that is probably a better option. Questions on that one? Okay, that is just kind of dumb luck that it is every third of a rotation. So yeah, if you spot those, that's fantastic. Now I can also use them for something that's really complex like this. If I were not allowed to have a graphing calculator, and I needed to be able to generate a graph of this. Graphing 3 minus 6 sine squared x, there's a lot going on there that I really don't want to try to mess with. Okay? One thing you can do, though, is just change what it looks like. I see something minus sine squared, right? So I want to modify this a little bit. If I take out the greatest common factor of this thing, what's the greatest common factor? 3. That leaves me with 1 minus 2 sine squared x. Well, what's 1 minus 2 sine squared x equal to? Yeah, and the u in this case would be the x, so it's just replaced with cosine 2x. Well, the nice thing is all this is taking regular cosine and doing what modifications to it? Changing the amplitude to 3 and change the period to pi. Because you have the 3 out front is going to change the amplitude. The 2 there is going to take 2 pi divided by that 2. So the period is going to be pi. So this thing that says it wants you to graph it from 0 to 2 pi. But I know this thing is going to complete one full cycle within pi, so I'm going to put those there. Now the nice thing about cosine, this is just 3 times it. So where is it going to hit the y-axis at? Up at 3. When's it going to hit? Where else is it going to hit? Be up at 3. And 2 pi. Where's it going to be at the bottom? Say again. Where's it going to be at the bottom at? Yep, pi over 2 and 3 pi over 2. And it's going to cross the x-axis halfway between each. So you end up getting 2 full cycles. That's a horrible one. Of cosine of x. Or cosine 2x. This is a heck of a lot easier to be able to graph without a graphing calculator than what this is. Questions on those? Okay. Might have something like this too, where they're giving you what sine of u is and ask you to find sine of double that, cosine of double that, and tangent of double that. Okay. Now the trick is sine and cosine both use. Well, actually, I could do the one cosine 2u. I can actually just use the sine. Sine 2u, though, I need to know what for? Cosine. Tangent, I need to know tangent, and to get tangent, I need cosine as well. Well, at least part of it. So I do need to actually generate this. If I have sine as 3/5, I'm going to use that triangle method. You could also use the Pythagorean identities and sine squared plus cosine squared equals 1. For this, though, what's the sine u equals 3/5? Tell me. As far as the right triangle goes. Yeah, opposite's 3, hypotenuse is 5. The adjacent then would be 4. Okay, so when I go to do this, it tells me u has to be in the first quadrant. So then everything's going to be what? Positive, so I don't need to worry about that at all. So if I want cosine, or if I want sine of 2u, well, sine of 2u is equal to, let's go down here with it, 2 times sine u, cosine u. Well, what's sine u? 3/5. And cosine u? 4/5. So all you do is multiply them out. What do you get? 24/25. For cosine 2u, okay, for this one I'd probably honestly just do 1 minus 2 sine u. Just in case I happen to screw up the triangle, I would still get this one right then because they gave me sine in the first place. So when I do this, I'm going to square the sine u. So I'm going to take 1 minus 2 times the sine u was 3/5 squared. Well, 3/5 squared is what? 9/25. So I have 2 times 9/25. So that's going to give me 1 minus 18/25. Which is what? 7/25. Do 25 over 25 minus 18 over 25 gives you 7 over 25. So there's those two. Now this is where you could use the tangent formula if you like, but that tangent formula was 2 tangent over 1 minus tangent squared. I know sine and cosine. I can just shortcut it. Do sine 2u divided by cosine 2u. Well, that's 24/25 divided by 7/25 is the same as multiplying by what? 25/7, which means,
The 25's cancel out.
and you're left with
24/7.
24/7. So 24 over 25, 7 over 25, and 24 over 7. Now for a fun one. Derive a triple angle formula, because those were double angle formulas. You want to derive or figure out a triple angle formula for cosine 3x. Okay, so we're going to build these. Now, the thing is, well, I don't know one directly, so I need to separate this out into pieces that I do know. What could I do?
Cosine of x and cosine of 2x. Is that not?
Well, the problem is those you can't just combine them together. It's not like square. Actually, it's essentially like having the same or having different bases. But I can separate out into a single cosine of 2x plus x. I can't do 2 separate cosines, but I can do a single one. Now this is just like section 4, where we're dealing with the sum and difference formulas. So I can essentially do just like this and split it up. This is going to be the same as cosine of the first times cosine of the second. Since this is plus and we're doing cosine, it switches to minus. Sine of the first times cosine or times sine of the second. Now the problem is there I'm mixing the 2 x's, so I need to replace the 2 x's. Well, we have formulas for that, the double angle ones. Sine 2x, the nice thing there is I only have one option. That's 2 sine of x cosine of x times sine of x. Now I want to make this as simple as possible, so I'd probably like to, if I could, stick with just cosine or just sine. It's not going to be able to get to just cosine, or just sine I should say, but I do have sine squared here. This side will turn into 2 sine squared cosine. And what's sine squared equal to? 1 minus cosine squared. So I can actually get this down to 1 minus cosine squared x times cosine. Okay. The left side, though, that one, well, I can just directly replace cosine 2x with something that only has cosine in it. I can just replace this with 2 cosine squared x minus 1 times cosine of x. Okay. So we got a lot of the same pieces floating around, so hopefully stuff will start canceling off. So I'm going to distribute the cosine of x here. What's that going to give me? 2 cosine cubed x minus cosine of x. Distribute this one. I'm going to distribute both the 2 and the cosine at the same time, giving me negative 2 cosine x. And then negative times the negative is going to be plus 2 cosine cubed x. So what do you notice? What can combine together? 4 cosine cubed x. Yeah, minus that 3 cosine x. So the idea is you get cosine of 3x is equal to that. And it's one of those things. If you don't know cosine of 3x, but you do know cosine of x, you can work with it that way. Now, there's actually a lot of different formulas you can generate for this. Because cosine 2x has 3 different possibles, you can actually generate a few different things. First we came up with a slightly different version because they decided to go a different direction. But if you actually replace or use 1 minus 2 sine squared, you actually end up with cosine of x minus 4 sine squared cosine.
I like ours better.
Yeah, I do too. There I gave more options. You guys are kind of led in a direction. So actually, when they say derive a formula, you actually need all of this work. If it said that on a test, you need to be able to show me all that. Okay, it's not going to be something where you can just write the answer. It's also a test where your calculator is going to be very, very little help to you. Another thing, besides those double angles, we also have power reducing. Power reducing formulas allow you to take something that's squared and bring it down a level to a linear. Okay, now notice, everything turns into cosine, but it turns into cosine of 2x. So if you have sine squared x, that's 1 minus cosine 2x. Cosine squared is 1 plus cosine 2x. And since tangent is just sine over cosine, the 2's cancel and you get 1 minus cosine over 1 plus cosine. Those ones aren't too bad as far as the memorization goes. Okay? It's just how the relationship works out. Now, go ahead.
Did you say you can cancel the 2's on the tangent?
When you do sine divided by cosine, if you were to do that, you would get this. Yeah. Not the 2u's, no. Because that's inside the cosine and there's minus signs going on and other stuff.
Okay.
This is a common spot where this is used in calculus because tangent to the 4th power, anything where it's like that large of a power gets really hard to manipulate. So what you do in calculus is reduce things down so you just have cosine to the 1st power or sine to the 1st power, things like that. Because those are much, much easier to perform derivatives and integrals on than where you have tangent to the 4th. Okay? So that's what they'll be phrased something like this. I want to rewrite this tangent to the 4th power as a quotient of 1st powers of cosine and multiple angles. So I don't care as far as whether it's 2u, 8u, anything like that inside of it. I just want everything to be cosine to the 1st. Okay? Now, tangent to the 4th, I don't have a direct formula for that up here, but I do have tangent squared. So what can I do with tangent to the 4th?
Tangent squared x, tangent squared.
Yeah, tangent squared squared essentially. So you have tangent squared times tangent squared. So that's what I want to replace this with, is tangent squared x times tangent squared x. So then I'm going to replace both of those tangent squared x with 1 minus cosine 2x over 1 plus cosine 2x. And then I'm going to multiply these together. Okay? Some of these can end up taking a decent amount of time because when I multiply these together, what am I going to get on the top? 1 minus cosine 2x and then cosine squared 2x. Okay, you don't multiply together what's inside the cosine, you're just squaring the operation, what's there. Okay, everybody see that? If we FOIL out the numerators, we get that. The bottom's going to look very similar. What's the only difference going to be? Yeah, all your signs are plus. So 1 plus 2 cosine 2x plus cosine squared 2x. Are we done? No.
First power.
Because we want everything to the 1st power. So I need to now take the cosine squareds and replace them with that 1 plus cosine 2x over 2. Okay? Now, there's an easy mistake that students end up making on this quite often. Because when I replace this piece of the numerator with that fraction, it's 1 plus cosine, but then it actually says 2u. What's 2u going to be in this case? No, because it was 2x before. So I need to double whatever's inside of this. So that's going to turn into 4x. Common mistake there will be to leave that as a 2x. Okay, because you're doubling whatever was there when it was still squared. The bottom again is going to look exactly the same, except for all positive. Now the bad part, because of all these plus signs and minus signs, nothing simplifies.
So that's the simplest.
No, because I can't have fractions inside. So I need a way to get rid of those fractions inside of fractions. Any ideas? Multiply what by 2? Everything, top and bottom. If I multiply top and bottom of this by 2 over 2, it's going to have to distribute through each term, but it's, when it gets to this one, it's going to cancel that denominator. 2 times the 1 is going to give me 2 minus what?
Would it be 4x after the cosine?
No, it's still 2x, because that cosine of 2x is one combined thing.
Okay.
The 4 can't just get inside of that. Then, though, after that, you're going to have what? Yeah, just 1 plus cosine 4x. Because that 2 is just going to cancel for that last thing that you're adding on. Bottom's going to look exactly the same, except for all pluses. Then I can clean it up a little bit, because I do have some like terms. What do I got?
The 1
Now, will these combine together?
no.
No, because one's 2x and one's 4x. So actually, the only thing that you can actually combine here is the 3 out front, and then you have minus the 4 cosine 2x. Yep, again, exactly the same, just plus. That would be your answer. And the thing is, in reality, with some of the properties that you'll learn later for calculus, this is easier to deal with than this. Okay? And they are equivalent statements. If you actually tried to graph tangent to the 4x to the 4th x on your calculator and graph this, it would be overlapping. They'd be the same graph. Questions on that? Okay. Let's do. Let's see.
Those are that small.
Yeah, let's keep going. What?
I thought those were so much bigger. Like this.
It's half sheet. Half angle formulas. These are the opposite of the double angle formulas. Instead of having 2u inside the trig function, you have u over 2. Now notice though, the nice thing is these look a lot like those power reducing ones, except for its square root. The reason they put plus or minus there though is because you're always going to have to figure out what quadrant that u over 2 is in. Because if you're doing cosine, where that u over 2, that angle u over 2 I should say, is going to dictate whether you get positive or negative. So, and sine or tangent has the two different versions as well. Okay, so here, find the exact value of cosine of 105. Well, I don't know 105 off the top of my head, but if I consider 105 to be u over 2, then what's u? 10. U would have to be 210, because this is equivalent to cosine of 210 over 2. Well, 210 degrees, the nice thing there is I actually know what that is on the unit circle, so I can work with that. Okay, so I'm going to set this up. If that u is 210, then this is going to be plus or minus the square root of 1 plus cosine of 210 over 2. Now I want to look back at the original real quick. Cosine of 105. At 105 degrees, is cosine going to be positive or negative? Negative. So I don't need the positive here. I just need that negative sign. Okay. Then go from there and simplify. What is the cosine of 210? Yeah, it'd be negative square root of 3 over 2. Another problem is I do need to clean this up. I can't have fractions mixed inside of radicals mixed inside of other fractions. Okay? So, where would I start then to clean that up? Make the top one fraction. So I'm going to do 2 over 2 plus negative root 3 over 2. Now let's do minus root 3 over 2. Okay. Then those will actually combine together. So I get 2 minus the square root of 3 all over 2 divided by 2. And that 2 is actually over what? On the bottom? 1. So that way I'm dividing two fractions. Right? So then multiply by the reciprocal. I get negative square root 2 minus the square root of 3 over 2 times 1/2. So what's my denominator going to become? 4. So I have negative square root 2 minus the square root of 3 over 4. The nice thing here is, what can I do? Yeah, I can actually square root the denominator there. So I end up with negative square root of 2 minus the square root of 3 all over 2.
That's an acceptable answer.
That's an acceptable answer.
Cool.
That's an exact answer for cosine of 105. So people like the cosine of 60 and cosine of 30 a lot better.
I don't know why I don't make theorems about the cosine of 105.
Trigonometry is actually in college, if you take it, it's a full semester course where you have all those as well.
Yeah. And the cosine of 105 obviously equals negative square root of 2 minus the square root of 3 divided by 2.
Obviously.
It does. I don't know why I don't make theorems about
Okay.
it.
Let's do one more. We'll do the product of sum and some of the product formulas tomorrow. Find all solutions to this problem. Between 0 and 2 pi. Any ideas where I'd want to start?
The half one.
I can't just get rid of the squared because that would change the values. The nice thing is about sine squared of x over 2, if I can move that squared sign, that's the same as this, right? Well, sine of x over 2, what does that convert into? That's the square root, plus or minus the square root of 1 minus cosine of the x, the numerator there, over 2. And since I'm squaring that, what's going to happen to the plus or minus and the square root? Those are gone. So it's just going to turn into 1 minus cosine x over 2 equals cosine squared x. Then what I need to do in order to solve this?
I'm confused what you got from that first step.
I'm literally using that formula from the previous page to replace sine of u over 2 with what it's equal to. Now these half angle ones, these are the ones that are not in the textbook, I don't think, on the front. This is on page 805, or 408, sorry. So you will want to get these memorized as well. But just those three things. And if you know the power reducing, they look a lot like those. So I'm replacing sine of u over 2 with that. And since I had sine of x over 2 squared, when I plug that in, I'm going to square that whole thing. Okay? So when I square that whole thing, the plus or minus it becomes irrelevant and the squared goes away. Okay? Then I end up with the cosine squared still on the left equals 1 minus cosine over 2. So then what do I need to do next in order to be able to solve this?
Cross multiply, then subtract the 1 and add cosine.
Yeah, cross multiply is really unnecessary because you're dividing by 2. You can just multiply by 2. You don't need to bother multiplying by 1. If I multiply both sides by 2, I get 2 cosine squared x is equal to 1 minus cosine of x. Then move everything over to one side to make it equal 0. Then what? Factor it. And actually, this is exactly the same as the first problem we did. You get the exact same thing. 2 cosine x minus 1 times cosine of x plus 1. So when I did that, that gave me pi over 3 and 5 pi over 3 as well as pi. Do I need to add the plus 2 pi in?
Nope,
Why not?
because it says between.
Yeah, this one says on the interval. So these three are my answer. Questions on any of it? Okay. Go ahead, Austin.
How come I think it's like the third to last step you don't use the double angle formulas? Up one, right? Up right there. Yeah.
Double angle refers to the angle being doubled, not the trig ratio being doubled.
Yeah, but
So it'd have to be 2x there.
but the like what you could convert it to would be 2 cosine squared x.
That's what I have.
Yeah. You could convert that back to cosine intermediate.
Why?
I just feel like that'd be simple.
But we earlier we couldn't go anywhere with that, so we changed it into this in the first place.
Okay.
Because that was the first problem we did today, right?
Yeah.
Yeah, you start off with cosine 2x and cosine of x. You don't want to try to...
So I don't ever want cosine of 2x. At least for now.
Depends. If you're trying to solve for x, not really. If you can avoid it.
Okay.
Sometimes.
Sometimes.
Okay. At least if you have to factor with it. Tomorrow we'll look at product to sum and sum to product. Friday we'll basically just have a review day for the section 5.5 stuff. I expect it to take a couple days for people to get used to it. And then Monday will be review as well. Tuesday is going to be the chapter 5 test.